The world is facing an energy crisis. In the coming decades, innovation is necessary to meet the skyrocketing demands of the exponentially growing world population. Today, energy production is dominated by energy generation systems that are primitive and out of date, and have wrought the world with pollution, deforestation, and depleted fuel reserves. The use of fossil fuels and non-renewable energy has had a devastating effect on the global ecosystem. Carbon emissions are at an all-time high and are still increasing at an unprecedented rate. The critical situation of the energy crisis, both exiguous and environmentally detrimental, is one that must be immediately addressed. With the world population set to double by 2050, it is vital to find new ways of producing clean and efficient energy. To find a solution to this urgent dilemma, our team investigated the state of energy production, distribution, and management in the United States. Though the state of energy generation has been significantly advanced in recent decades with the development of solar, wind, hydroelectric, and geothermal energy, advances in grid energy systems have remained relatively stagnant. In order to maximize the potential of these clean energy generation methods, we sought to enhance the effectiveness and efficiency of energy storage and distribution by improving grid energy systems. After months of research, development, and prototypes, we introduced our innovation into the field of energy grid technology that will revolutionize the way energy is generated and used, the NERO Battery. The NERO Battery provides a sustainable alternative to fossil fuels, capable of improving energy generation and storage methods. The battery derives its energy singularly from natural environmental temperature fluctuations. The battery is divided into 3 partitions. The innermost is a flexible chamber filled with pure gallium, a metal with a melting point of 85 degrees Fahrenheit. The chamber is surrounded by a layer of piezoelectric ceramic. This unique material generates energy when mechanically displaced. As ambient temperatures fluctuate above and below the melting point of the gallium core, it expands and contracts as it shifts back and forth from solid to liquid. This mechanical deformation causes the chamber to exert pressure and alter the shape of the piezoelectric ceramic, generating energy. The battery's graphene storage layer charges and discharges faster due to the material's increased electron mobility and nano-sized thinness. Nanographene is a thin layer of pure carbon and is one of the lightest materials known to man, as well as one of the strongest compounds manufacturable. Thanks to its large surface area, 1 gram of activated nanographene can have an estimated surface area equal to that of an entire tennis court, allowing it extremely efficient energy storage and an expanded lifespan. The nanographene battery's storage capacity is 100 times greater than that of its most common modern competitor, the lithium-ion battery. Furthermore, the NERO battery would minimize the energy loss in periodic discharge due to the nanographene's density and ability to retain structural charge. As grid technology moves forward, the future lies in the industrialization and privatization of energy systems. By transitioning from widespread electrical networks, we can say goodbye to the antiquated and technologically outmodeled grid systems of the past, dominated by archaic electrical towers and massive myriad transformers, and say hello to a future of secure, efficient, and sustainable power for everyone. We have designed the NERO battery itself to be structurally modular and can be individualized, allowing for the battery to be marketed and implemented on a variety of scales and into a variety of systems. Another key feature is the battery's ability to undergo cycles on its own. It generates energy solely from the natural daily changes in outside temperature, requiring no external input or management. Additionally, all components of the battery are biodegradable and non-toxic, meaning that any potential leakage poses no safety or environmental threats. The NERO battery will be used to replace private, corporate, and industrial grid energy storage systems, providing increased storage and efficiency, as well as generating internal energy independently. The United States grid energy storage industry currently relies on large lithium-ion batteries in centralized systems. In order to sidestep the inefficiency of these large-scale electrical grids and individualize sustainable energy production, the NERO battery will introduce a shift towards smaller energy reservoirs. Replacing current systems with the NERO battery would allow for steady energy independence and the elimination of the costly and restrictive modern energy grid. With individualized energy systems, the era of power outages and shortages would be long past. The NERO battery will revolutionize the energy industry with its superior storage capabilities, ability to renewably and cyclically generate energy, and ease of distribution through charge mobility. With the NERO battery, long gone is the age of primitive electrical grid technology denoted by blackouts, inefficiency, and unshakable reliance on non-renewable energy. The NERO battery provides a sustainable alternative to outdated grid energy storage technology. This technology is capable of ushering in a new era of production, storage, and distribution, one vastly improving grid energy systems and revolutionizing clean energy production. Thank you for considering us for the Conrad Spirit of Innovation Challenge.